Hello, ladies and gentlemen. Today we're going to look at graphing sine and cosine functions. And we're going to start with the sine of theta. F of x is equal to sine of theta. And we're going to graph that from 0 to 2 pi. All right, now we've already got the x-axis here. All right, and it's labeled. All right, the y-axis is labeled as well. All right. And if this is pi, there are 6 plus 6 more, 12 parts from 0 to pi. So each part is pi over 12. So this would be 1 pi over 12. This would be 2 pi over 12, but that reduces to pi over 6. This would be 3 pi over 12, which reduces to pi over 4. All right, this would be 4 pi over 12, which reduces to pi over 3. All right, this is 5 pi over 12, which doesn't reduce. All right, so we'll leave that alone. 6 pi over 12 reduces to pi over 2. 7 pi over 12 does not reduce, so we'll leave that alone. 8 pi over 12 reduces to 2 pi over 3. All right. 9 pi over 12 reduces to 3 pi over 4. 10 pi over 12 reduces to 5 pi over 6. 11 pi over 12 does not reduce, and that's 12 pi over 12. 13 pi over 12, all right, doesn't reduce. We'll leave that alone. 14 pi over 12 does reduce to 7 pi over 6, all right. That was 14. 15 pi over 12 reduces to 5 pi over 4, all right. And 16 pi over 12 reduces to 4 pi over 3, all right. And 17 pi over 12 doesn't reduce. 18 pi over 12 reduces to 3 pi over 2. 19 pi over 12 does not reduce. We'll leave that alone. 20 pi over 12 reduces to 5 pi over 3. All right. 21 pi over 12 reduces to, 7 pi. Oops, I shouldn't have wrote that. 7 pi over 4. 22 pi over 12 is 11 pi over 6. And then 23 pi over 12 does not reduce. 24 pi over 12 is 2 pi. All right. And those are your values, and you can put those down here where the cosine is as well. I'm not going to do it. I think we can figure it out from there. Okay. All right. So let's start with 0. So what's the sine of 0? Well, if you go to your unit circle, the sine is that y-coordinate right there is 0. So that's this point right here, 0, 0. All right. Pi over 12 is not on the unit circle, so we're not going to mess with that. We'll go to pi over 6, and we'll get the sine. The sine of pi over 6 is 1/2, okay? All right, so 1/2 would be approximately right there, okay? And then pi over 4, we want the sine of that. That's square root of 2 over 2. Now let's talk about a decimal equivalent for the square root of 2 over 2, and we will approximate that real quick. All right, and I'll just do that on my calculator here where you can see that. The square root of 2 divided by 2 is about 0.7, all right? So that's approximately 0.7, all right? So at pi over 4, we get about 0.7, okay, which is right in there somewhere. All right, the sine of pi over 3. Well, here's pi over 3. The sine is the square root of 3 over 2. Well, the square root of 3 divided by 2. Well, let's get a decimal approximation for that as well. The square root of 3 divided by 2 is approximately that's about 0.9 if you rounded it to the nearest tenth. Okay, so that's up here at about 0.9. All right, 5 pi over 12 is not on the unit circle, but pi over 2 is, and the sine is 1. So that sine is 1. All right, 7 pi over 12 is not on the unit circle, but 2 pi over 3 is, all right, and the sine is the square root of 3 over 2, which we approximated a moment ago to about 0.9 up in there. All right, and then 3/4 pi is square root 2 over 2, which we approximated to be about 0.7. All right, and then 5 pi over 6, 5 pi over 6, the sign is 1/2. So that's 1/2, which is approximately right there. Okay, 11 pi over 12 is not on there, but pi is. The sign of pi is 0. Okay, so 0. All right, 13 pi over 12 is not on the unit circle, but 7 pi over 6 is. The sign is negative 1/2, so that's negative 1/2. All right, and then we're going to go to 5 pi over 4. The sign is negative, the square root 2 over 2. Well, that's negative 0.7. Okay, so negative 0.7, which would be in here. All right. And then we're going to go to 4 pi over 3. The sign is negative, negative 0.9 basically. Okay, so negative 0.9. All right. And 17 pi over 12 is not on the unit circle, but 3 pi over 2 is, and that sign is negative 1. All right, so that's that point. 19 pi over 12 is not on your unit circle, so we'll go to 5 pi over 3. All right. The sign of 5 pi over 3 is negative 0.9. All right, so that's negative 0.9. All right, and 7 pi over 4, the sign is negative square root 2 over 2, which is about negative 0.7. Okay, all right, and then 11 pi over 6, 11 pi over 6 is negative 1/2, negative 1/2. All right, and 23 pi over 12 is not on there, but 2 pi is. The sign of 2 pi is 0. All right, so we can now plot all the points between those. All right, so that graph would come up through here. All right, then it would come down through here. All right, and come all the way over to there. So there is the graph of the sine function. F of theta is equal to the sine of theta from 0 to 2 pi for the domain of theta. All right, and now let's go and graph the cosine of theta, okay? All right, if we want to graph the cosine from 0 to 2 pi, let's go and you can imagine pi over 12. If you want to write these down, you could. Here, let's just do it real quick. Pi over 12, pi over 6, pi over 4. It's the same ones we just had up there. Pi over 3, 5 pi over, we'll write 5 pi over 12. That's fine. All right, 7 pi over 12, 7 pi over 12, 2 pi over 3, 3 pi over 4. These are all the ones that are on the unit circle, plus a few more that we don't have on the unit circle, but that's okay. We don't need those. 11 pi over 12. 13 pi over 12. All right, 7 pi over 12, or excuse me, over 6. 5 pi over 4. All right, 4 pi over 3. 17 pi over 12. All right, 19 pi over 12. The next one is 5 pi over 3. That's pi over 3. 7 pi over 4. 11 pi over 6. And then 23 pi over 12. And there you've got them all listed again. Okay, so let's go, and first of all, we're going to do the cosine this time. So we go to 0 and get the cosine. Well, that cosine is 1. So when theta is 0, the cosine of theta is 1, which is that point 0, 1. All right, on your graph. Now, pi over 6 is next. We want the cosine, which is the square root of 3 over 2. Square root of 3 over 2 is 0.9, so that's up in here, 0.9. All right, next is pi over 4. The cosine is square root of 2 over 2, which is about 0.7. Remember that from up above, 0.7, which would be up in there. All right, pi over 3 is next. The cosine is 1/2. All right, so pi over 3, we get 1/2. All right, 5 pi over 12 is not on the unit circle, but pi over 2 is. That's up here. The cosine is 0. So that's this point right here. All right, and we skipped 7 pi over 12 because it's not on the unit circle. We'll go to 2/3 pi, And at 2/3 pi, the cosine is negative 1/2. All right, so negative 1/2. Oops, not there. Not there. Okay, I'm sorry. All right, and then 3 pi over 4, the cosine is negative square root of 2 over 2, which is about negative 0.7, down in here. All right, and at 5 pi over 6, which is right here, we get negative the square root of 3 over 2, which is about negative 0.9. Okay, negative 0.9. 11 pi over 12 is not on the unit circle, but pi is, and the cosine of pi is negative 1, all right, which is right here, negative 1. 13 pi over 12 is not on the unit circle, but 7 pi over 6 is. The cosine is negative square root of 3 over 2, and that's about negative 0.9. Okay, negative 0.9, round in there somewhere. And then 5 pi over 4, 5 pi over 4, the cosine is negative square root of 2 over 2, which is about negative 0.7, okay, negative 0.7. And then 4 pi over 3, 4 pi over 3, the cosine is negative 1/2, all right, negative 1/2, all right. 17 pi over 12 is not on the unit circle, but 3 pi over 2 is. Here's 3 pi over 2, the cosine is 0. So that's that point right there, all right. 19 pi over 12 is not on the unit circle, but 5 pi over 3 is. There it is, and that's the positive 1/2, approximately there. And then 7 pi over 4, the cosine is square root of 2 over 2, which is about 0.7, around in there, okay? And 11 pi over 6, the cosine is the square root of 3 over 2, which is about 0.9 up here. 23 pi over 12 is not on there, so we'll go to 2 pi, and that's positive 1, okay? All right, is the cosine. So now you can just take and graph those points. Okay, those through each of those comes down through here, all right, to there, and then it comes up and over like that right there. So there is the graph of f of theta equal to cosine of theta, all right? And now what we need to realize is this, okay? Those are both what we call sinusoids, all right, which is wave functions, all right? And they're oscillating between positive 1 and negative 1, all right? And they have what's called an amplitude, all right? And I'm just going to tell you that that's the absolute value of A. The absolute value of A is equal to the amplitude, all right? All right, and I will tell you that that is the distance all right, from a maximum, all right, from a maximum value or a minimum to the midline. Now, the midline is basically where it crosses the x-axis. All right, I would just tell you that's the midline there. Here's the midline here. All right, I also like to call the line containing all of the maximums as that line right there, and the line containing all of the minimums, I like to call that line right there. That helps me make this graph real quickly, and I would like for you to learn those terminologies. All right, so there's your 3 lines, all right, and the amplitude is the distance between the midline and the line containing the maximum, or the distance between the line containing the minimums and the midline. Okay, all right, so the distance from a minimum or maximum to the midline, all right. All right, so there's what we'll talk about that. All right, now a period. A period is the distance to complete a full cycle. Let's write that down here. Okay, a period is the horizontal distance for the graph to complete a full cycle. Complete a full cycle. Now, you could define a full cycle from one maximum all the way over to another maximum, or from one minimum all the way over to another minimum, or from a midline point. Now notice that it's coming down to another midline point coming down, so you got to be careful about that, all right? So anyway, you need to realize that we have what's called, when you transform these graphs, which is what we're getting ready to do and make graphs of transformations, that your new period, because you can change the period, all right, your new period can be found by taking the normal period, and we'll talk about that in just a moment, the normal period, all right, divided by the absolute value of b. Oops, and I meant to do that. And by the way, the normal period, what is the normal period? How long did it take to go from this maximum to that maximum? Well, the new normal period here would be 2 pi. All right, well, how long did it take from going up at a midline point to going back up again? That is also 2 pi. All right, so that's the period for both the sine and the cosine without any transformations, for the parent functions, if you like. Okay, all right. That takes care of A. A is the absolute value. That gives you your amplitude. B gives you your period. C is the what we call a phase shift, okay? All right, so your phase shift is found by using C, all right? And that's your horizontal translation. And of course, D is your vertical translation, all right? But one thing you might want to know about, we'll talk about that vertical shift as well, okay? All right, and let's talk about C, this phase shift. All right, you want to be able to find what's called the phase shift, and if you take, all right, to find the phase shift, this is what I would do. Take the expression b times x minus c and set that equal to 0 and solve. And solve that for x, and that will give you what's called the beginning point. Oops, can you see that? Move that so you can see it. The beginning point, okay, all right. And the next thing you would need to know is that your beginning point plus your new period would be the ending point. Because we're going to, in a sine and a cosine graph, we're going to always graph at minimal one period, okay? All right, so add the period, the new period, I should say, add the new period to the beginning point, to get the ending point. Now, these graphs do never end, so don't think of it that way. We're just only going to graph one period. That graph goes forever. I'm going to show you that in just a second. Add the new period to the beginning point to get the ending point. Let me write that down first. Yes, if you go on here and you graph, I'm going to do this real quick, and those theta's in radians, so I'm going to make sure I'm in radian mode first of all, okay? If I go into and graph the sine of theta, all right, there's the sine of theta, all right, and if I graph that, you can see that it goes forever in both directions, and you can check your table and see that, all right? So the graph, we really technically don't have a beginning point, but when we make a graph, we got to start somewhere. So we have what's called a beginning point and an ending point, all right, and that's how you find those. All right, so now let's go look at doing some transformations. All right, let's first of all find the amplitude. The amplitude is the absolute value of A, all right? And if we look at this equation, A is the number in front of that sign out there, 4, so that amplitude is 4, okay. All right, next let's find the period. The length of one period is the original period, 2 pi, divided by the absolute value of B, Well, this time b is 2, all right? So that would be 2 pi divided by 2, which would just be equal to pi. All right, that's the length of one period. Your phase shift, if you were to take 2 pi and set that equal to 0 and solve it for x, you would get x is equal to 0. So that means there is no phase shift. The vertical shift, that's d, that constant term up there. And there is none, so you can write 0 or none, whatever you want, all right? Either one would be fine with me. Your beginning point. Well, your beginning point would be to take, excuse me, the beginning point is found by taking that expression, setting it equal to 0, and we've already done that, so that your beginning point would be 0. And now your ending point for one period would be 0 plus your new period, which we found to be pi, all right, which would just be pi. So there's your ending point. All right, now I like to make my graph stretch all the way across my coordinate system, all right? And the first thing I would ask is there a vertical shift up or down? Because if there is, I would take care of my x-axis that way first, because I want to put my x-axis. And there is no vertical shift, so I'm just going to put my x-axis right through the center here. Okay, all right. So there's my x-axis. All right, now, if there's no phase shift, I'm going to put my y-axis here at the beginning, all right, simply because that's where I want it, all right, so, and there was no phase shift, okay, it was 0, all right, so there's no phase shift, so we'll put the y-axis right here, all right, and I like to stretch my graph out as far across that grid as I can, so I'm going to go out there, and I'm going to say, okay, out here is my ending point. Well, my ending point is pi, so I'm going to make that pi. Well, if that's pi, and I believe there's 2, 4, 6, 8, 10, 12, 14, 16 boxes from 0 to pi, half of that, which is 8 boxes, would be pi over 2. So and by the way, I will tell you this. Once you get your new period and put it on there, if you will quarter it, okay, that will make this graph a lot easier. All right, so let's quarter it. So that's 16 divided by 4 is 4. So every 4, 1, 2, 3, 4. Okay, I'm going to put a little vertical line. So 1, 2, 3, 4. And then I'm going to come back and label those in just a moment. 1, 2, 3, 4. This is half of pi, pi over 2. Half of that is pi over 4, which would be this one here. All right, oops, that's a 4, excuse me. And if we did pi over 4 plus this, that would be 3 pi over 4. Okay, so this would be 3 pi over 4. And those get you your critical points, your maximums, your minimums, and the points where it crosses the midline. All right, now next I'm going to graph the line containing the maximums. Well, since there's no vertical, the midline stays on the x-axis, by the way, and I'm going to do my altitude of 1, 2, 3, 4, and there's the line that will contain all of the maximum points, okay? And if I go 1, 2, 3, 4 below, down at -4, there are all the points that would contain my minimums, okay? And now I'm graphing a sign. Now remember that the sign started at the origin, okay? All right, which would be here. Now, if you're having trouble with where I got that point, just put in a 0 for x and do 2 times 0 is 0, and do the sign of 0, all right, on your unit circle. The sign of 0 is 0, and then multiply that by 4, and that would give you the y-coordinate of 0, okay? All right, and now I'm going to input for just a second pi over 4. If I did 2 times pi over 4, that would give me pi over 2. And if I went to pi over 2 and got the sign, that's 1, and then I took that 1 and multiplied it times this 4, I would get 4. So at pi over 4, it's 4, all right? And then I want to do pi over 2 next. I'm going to do 2 times pi over 2. 2 times pi over 2 would be 2 pi over 2, or just pi, and the sign of pi on your unit circle is 0, and 4 times 0 would be 0. So there's where it crossed the midline. All right, and then now by now you know that the next one is going to go down all the way to that minimum, and then it's going to come back to that midline. So that graph will come up through here, all right? It will then come down through here, all right, all the way over to here. It will then curve back up to that point right there, and there's that graph. And I would tell you that you can, if you want to, graph that, all right, on your calculator so you can see what it looks like. If you were to go into the y equals and type in 4 times the sine of 2x, all right? And now what I would want you to be able to look at is this. I would want you to change your window settings on your calculator to match the window settings on our paper. Well, the minimum x-coordinate is this x-coordinate 0. The maximum x-coordinate is pi, all right? And we're counting by pi over, let's see, there's 16, pi over 16 is what we're counting by, so just do pi divided by 16, okay? Horizontally, and now let's do vertically. The minimum y-coordinate down here is -4. The maximum is +4, and we're counting by ones, okay? And now when we hit graph, your graph should look a lot like our graph on our paper, okay? And that's one complete cycle, all right? Now, what I would also tell you is probably more useful would be to check your table. Okay, all right, let's start our table. So second table set up at 0, and let's count by pi over 4, because if we do, all right, you're gonna see the maximums, the midline points, the minimums, and the other midline point. All right, so let's go into our table. So here's 0, 0, all right. This point right here is pi over 4. If you were to take, and I'm going to do this real quick, if you were to take pi, divide that by 4, that x-coordinate is 0.785, and that's that value right there, okay? And that y-coordinate is 4, that's this point right here that you're looking at. This point is pi over 2. By the way, if you did pi divided by 2, you get the decimal of 1.57. Well, there's that number right there, 1.57, and the x-coordinate is 0. All right, and if you did 3/4 of pi, let me go back to, or 0.75 pi, same difference, okay? There, that x-coordinate is 2.356, all right? And then the y-coordinate for 2.356 should be this -4, so that is this point right here. And then at pi, which is 3.14, the y-coordinate is 0, so there you go. All right, now let's move on. In that next one, number 2, all right, we're going to first find the amplitude. Well, the amplitude is the absolute value of a, and that's the coefficient of the trig function. The coefficient is -1, all right, and the absolute value of -1 is +1. Next, we're going to find the length of the new period. Well, the original period for a sine is 2 pi, and we're going to divide that by the absolute value of b. This time, what we might need to do to make this look like our other one would be to factor that out. All right, the common factor away from that x, or the coefficient of x, let's factor that out. Well, the coefficient of that x is pi over 2, so we're going to do pi over 2 times x, and then if we divide this by pi over 2, we get +1, all right? And then, of course, +3 out here for your the rest of your equation. So you might have to rewrite the equation so you can see that that's what you get, okay? All right, so we're going to divide by the b value, so now we've got y equals a times the sine of b times x minus c plus d, so you can get it in the form you want it, okay? All right, and by the way, if you want to rewrite this as minus -1, you could. C would be -1. We'll deal with that in a minute. All right, but b is pi over 2, so that would be 2 pi times the reciprocal of pi over 2, which is 2 over pi, all right? And those pi's will cancel, which means that the length of your period is 2 times 2, or 4, all right? Your phase shift is the c value, okay, which is the -1. That's your phase shift. And your vertical shift is your d value, and it's positive, so that means it's 3, or if you want to say 3 units up, that's what, in essence, what's going to happen, okay? And your beginning point, if you were to take pi over 2 times x plus 1 and set that equal to 0, all right? You could multiply each side by 2 over pi. 2 over pi is what I would do, all right? Which means x plus 1 would equal 0, which means x would equal -1, all right? So there's your beginning point right there, -1. Now we're going to find our ending point. Remember, to find your ending point, you need to take your beginning point and add your new period. Okay, so the ending point would be -1 plus the period of 4, which would give us a +3. So our graph horizontally will go from -1 all the way up to +3. Okay, all right. Now, let's talk about the x-axis first. Was there a vertical shift? And the answer is yes, there was. It was shifted 3 units up. So what I want to do is I'm going to move my x-axis maybe down a few, at least 2 or 3. Let's go down 2. All right. So there's my x-axis right there. To accommodate for the vertical shift up, I move my x-axis down. Okay. All right. And was there a shift left or right? And the answer is, oh, yes, there was. There was a phase shift. It's to the left, okay? All right. And what I want to do is I want to account for that by moving my y-axis to the right a little bit. So I have this -1 here. And I don't know. I'm thinking I would count by, if I wanted, I could go all the way out there. Let's do it. Okay, if we quarter it, that'd be every 4, wouldn't it? Okay, so let's quarter it. So 1, 2, 3, 4. Let's see, 1, 2, 3, 4. We'll quarter it right here. Okay, all right. And then I'll put this one here, and then I'll go 4 more. 1, 2, 3, 4. All right, and then 1, 2, 3, 4. And then 1, 2, 3, 4. Okay. So over here is my beginning point, -1. Over here is +3, and this would be 0, 1, and 2. Okay, all right. And now I want my midline. My midline normally on the sine or cosine parent function is the x-axis, all right? But it's been translated 3 units up, so I'm going to go up 1, 2, 3, and I'm going to put that midline right there. There's your midline right there, okay, at 3. The amplitude is 1, so I'm going to go 1 unit above that line and put the line containing the maximums, okay, and I'm going to go 1 unit below that and put the lines containing the minimums. Okay, all right, and now I'm going to input a -1 first, okay, and it might be helpful if I did it right here, because if I input a -1 here, -1 plus 1 would be 0, and 0 times pi over 2 would be 0, and then I could find the sine of 0. The sine of 0 is 0. The opposite of 0 is 0, all right, and then I can just add 3 to that, and that would make that, oh, wait a minute, hold on, 0, all right. Let's put that in one more time. If I did 0, oh, wait a minute. If I put a 0 in, or -1 here, that would be 0. The sine is 0 plus 3. Yes, plus 3 would be 3. So 1, 2, 3 would put it right here. Okay. All right. That would put that point right there. Absolutely. Okay. All right. Now over here, I'm going to put in a 0. If I put in a 0 right here, 0 plus 1 is 1. 1 times pi over 2 is pi over 2. And the sine of pi over 2 is 1, all right? And the opposite of that is -1. And -1 plus 3 is +2. So it would be up here at this point right here. So it's going from the midline down to the line containing the maximums. Then it's going to go back up to the midline, and then back up to the maximums, and then back. All right, so that graph is going to come down through here. All right, come back up through here, over, and then it's going to come back down like that. And there's the graph of 1 period. All right. And once again, you can graph that on your calculator if you want to. I want you to see this. All right. let's go and put in the function, which was the opposite of the sign of alpha y1 to get a fraction, and pi x is the numerator, 2 is the denominator. Come out of that fraction, add yet another fraction. Oops, I need to get my fraction, alpha y1. All right, the numerator is pi. All right, the denominator is 2. Come out and close that off before you increase that by 3. All right, so there's the equation. Before I went and looked at the graph, I would then want to change the window on the calculator, so I'm going to do that next. My minimum x coordinate is right here at -1. All right, my maximum is 3, and it looks like we're counting by 0.25 or 1/4, okay? My minimum y coordinate is -2 on my graph. My maximum is, see, this was 2, 4, 6, okay? All right, and we're counting by ones vertically as well, all right? And now there's what your graph should look like. It should look like that right there, okay? All right, and it does. It looks very similar. It says, of course, there's an aspect ratio, but that's not a big deal. What would be way more important would be to check your table. If you set your table to start at this x coordinate, -1, and count by ones, because that's what we're looking at from these critical points, then the first point would be -1, 3. There it is, -1, 3. That's the ordered pair for this point. This point is 0, 2, so that should be the next one, 0, 2, which it is. This point is 1, 3, all right, so there's 1, 3. This point is 2, 4, all right, there it is right there, 2, 4, okay. This point has coordinates of 3, 3, and there's that point right there, and of course it keeps going, but we don't need to mess with that. All right, let's turn the page. Let's look at the next one. All right, the amplitude is the absolute value of A. In this case, A is the coefficient of the cosine, which is, excuse me, 2. And that means the amplitude is 2 because the absolute value of 2 is 2. The length of the new period would be 2 pi divided by the absolute value of 1/3. Okay, which would be 2 pi over 1 times the reciprocal of 1/3. The reciprocal of 1/3 is 3 over 1, all right, which would be 6 pi, all right? So there is your length of one period. All right, the phase shift is the value of C, basically, all right, which is pi over 2, all right? And the beginning point, well, the beginning point will also, if you were to take this expression, 1/3 times x minus pi over 2 and set it equal to 0, multiplied side by 3, x minus pi over 2 would be equal to 0, so x would be equal to pi over 2, all right? So there we go, that's pi over 2. And now we're going to find our ending point. Our ending point we find by taking pi over 2, our beginning point, and adding our new period. I'm going to make that a fraction, and then I'm going to say, okay, well, that's the same thing as pi over 2 plus, I need to multiply that by 2, so I've got to multiply that by 2. All right, and then I would get 13 pi over 2 is my ending point, excuse me, 13 pi over 2. All right, so I'm going to graph the x-axis first. Was there a vertical shift? And the answer is yes, it went down 3, didn't it? So in order to compensate for that, I'm going to go up at least a few. All right, I'm going to go up here and put my x-axis here. All right, and was there a phase shift? It was positive, and that means that I could, if I want to move it, if I want to, let's see, do I want to? Yeah, let's just do this. Let's just leave it where it's at. Unless there's a shift to the left, a negative vertical phase shift, I would just leave it where it's at. Try to leave the y-axis at the beginning of your graph. Okay, now you can't just quarter this thing because of the fact that we're not really starting at 0 and ending out here somewhere. So what we're going to have to do is find something good to count by. All right, 13 pi over 2, that's like 6.5 pi, all right? And it might be helpful if I went a little bit beyond that. So maybe go like to 8 pi, because it's a nice even number. All right, so I'm gonna make this right here 8 pi. If I do that, and I divide that by 16, I'm counting by basically pi over 2. So this is pi over 2, so there's pi over 2. By the way, that's your beginning point, okay? All right. And what you need to realize next is that we're going to have to go to, oh, by the way, here's pi. This one right here is pi. All right, so that's pi. There's another 2 pi right there, right? So 2 pi, 3 pi's right here. 1, 2, 4 pi, 5 pi, and 2 more is 6 pi. And by the way, I'm going all the way to right there. Okay, I have to go from here to there. All right, now if I go beyond or to the left, that's not important. It's okay if you do, you don't have to, but I definitely have to start from here and go to there because this is 13 pi over 2. Okay, all right, and now what I would do is this. I'd say, okay, that is how many units? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 boxes. I'm going to quarter that by dividing it by 4. So every third box, I'm going to put a vertical line. So 1, 2, 3, and I'm starting from my beginning point, by the way. And then 1, 2, 3. Okay. And then 1, 2, 3. And then 1, 2, 3, there would be my end point. If you'll quarter your period, that will make you help you make your graph real quick. All right, so next I'm going to, excuse me, I'm going to put in my midline. All right, normally it's at the x-axis unless there's a vertical translation, which there is, and it's down 3, so I'm going to go down 1, 2, 3, and that line right there contains my minimum, or that's my midline, excuse me. Now, the amplitude's 2, so I'm going to go 2 units above and put my line containing my maximums, okay, and 2 units below that midline to put my line containing my minimums. All right, now I'm going to start at pi over 2. If I put pi over 2 in here, pi over 2 minus pi over 2 is 0, all right? And then if I do 0 times 1/3, all right, I get 0. And the cosine of 0, all right, the cosine of 0 is 1. There's 0, and the cosine is the x-coordinate, 1. So I would do 2 times 1, which is 2, and 2 minus 3, which would be -1, okay? -1 would be that point right there. So when you input pi over 2, you get out a -1. Well, I know it's going to the midline next, okay, because it's got to go down. Then it's going to the minimum line, back to the midline, and then back to that line containing that maximum. So that graph would look pretty much like this right here. There's what that graph would look like if you graphed it one period. I'll leave the calculator up to you. You could do it on your own. Okay, all right. Let's go down to the next one. The amplitude can be found by doing the absolute value of -5, the coefficient of the trig function, which means that amplitude's 5. The length of one period, okay, well that would be, a cosine is 2 pi divided by the absolute value of b, and b in this case is 4. Well, that would be 2 pi divided by 4, which would be pi over 2. That's your period, pi over 2. Phase shift, that's basically your C value, which is pi over 3. Okay, the vertical shift, that's 1 unit up, or 1, you can write 1 up or 1, it's the same thing. The beginning point, all right, that's basically your phase shift, all right, so pi over 3. Then I'm going to take pi over 3, and I'm going to, excuse me, I'm going to add my new period to it. Well, my new period is pi over 2. All right, and if I want to add these two fractions, I need a common denominator. All right, that would be 6. This would be 2 pi over 6. That one would be 3 pi over 6. And when I add those, I get a ending point of 5 pi over 6. So 5 pi over 6. Okay, now, first thing is the x-axis, all right? If I'm gonna make my graph, I need to know, is there a vertical shift? There is, 1 unit up. Well, in order to compensate for that, I'm gonna come down 1 unit, all right? But you don't have to, you can go right through the middle, it doesn't really matter. Okay, I might have went through the middle anyway. Like I said, it doesn't matter. It's not that big of a shift. Okay, all right, y-axis. If there's a negative phase shift, I'm gonna move my y-axis to the right to accommodate that. There's not, so I'm just gonna say, okay, here's my y-axis, all right? Okay, all right, now, I have to go all the way from pi over 3 to 5 pi over 6. Well, I would like to count by a number that is a multiple of both 3 and 6, all right? Because I'm looking at these two denominators here, because I want to start here and end there, and that would be 12. All right, so I'm just going to count by pi over 12, all right? So pi over 12, 2 pi over 12 is pi over 6, 3 pi over 12 is pi over 4, all right? 4 pi over 12 is pi over 3, 5 pi over 12 does not reduce, all right? And 6 pi over 12 is pi over 2. 7 pi over 12 doesn't reduce, leave it alone. 8 pi over 12 is 2/3 of pi. 9 pi over 12 is 3 pi over 4. I'm going to bring that down here. 3 pi over 4 is right there. All right. 10 pi over 12 is the same thing as 5 pi over 6. 11 pi over 12, it doesn't reduce, does it? No. So I'm going to bring that one down here as well. 11 pi over 12. All right. 12 pi. All right. And then I need, that's this 11, 12, 13 pi over 12. Doesn't reduce. 14 pi over 12 is what, 7 pi over 6? 7 pi over 6. And have we got 5 pi over 6? Oh, we did. We could have quit earlier. Okay, so we're going to go from pi over 3, all right, pi over 3, which is right here, all right, all the way up to 5 pi over 6, which is right here. So we have to graph in between there. Now, if we graph more than what's in between there, that's okay with me. And I'm going to do that this time so you see what I'm talking about. All right, so between there is 1, 2, 3, 4, 5, 6 boxes. I'm going to quarter that. If you quarter 6, that's basically every 1.5, okay? And I'm going to put a vertical line on every 1.5, okay? All right, 1.5. And that gives you all you would need. I'm going to come back over here, 1.5, okay? 1.5. All right, and 1.5 really is what I need here. All right, I'm going to go a 1.5 from here, which would be here as well. 1.5 from there would be here. 1.5 from there would be here. All right, and I'll fill up the whole grid here just for fun, okay? All right, and now I want my midline. Well, the midline normally on the cosine is the x-axis. It's been shifted 1 unit up. Okay, so the midline will go right through here. This is your midline. I'm going to dot that midline. Okay, I'm going to dot that midline. All right, and then the amplitude is 5. Okay, well, I think I probably should, I can't count by 5 and get 10, so I'm going to count by 2s. Ooh, I should have done that. Well, let's do this. I always scale it. I can do 1, 2, 3, 4, 5 below. If I do that, I would be down here, all right? And 1, 2, 3, 4, 5. I would extend that if I had to. You can do that. That's not a problem with me. This will be the line containing the maximums. It's going to be 6 if you're counting by 1, 2, 3, 4, 5, 6, okay? All right, so that would be 6. All right, and now I'm going to go to my beginning point right here, all right, pi over 3, where is pi over 3? Right here, okay. pi over 3, and by the way, cosine starts normally on a maximum, all right, but the negative is going to reflect that and make that pi over 3 a minimum. So I'm going to be on this midline right here, okay? All right, down here at -4, and then I'm going to go to the midline, which is here, and then I'm going to go to the maximum, which would be over here, and then I'm going to come back down here. So technically, all right, really all I would need to graph would be this part right here, okay? All right, let me get it. Hang on just a moment. Oh, I'm coming down to here. And then come back down. I believe it's down here. Let's see. Over half, box and a half. Here, it should have been over here. My fault. Come over here. This should have come up to here, then down to here, and then that's back down to here. That's what it should have looked like, and really, at this point, we're running out of time, so I'm going to go ahead and quit. So that's really all you would need to graph. That's one period, okay? All right, let's turn the page. Next, it says to find the equation, and this is really hard to read, so you'll need to make your own graph, all right? Now, it really depends on whether you want to do a sine or a cosine. I'm going to do both real quick so you see that, okay? I'm going to start with a sine, all right? First thing I would want to know is, where is that midline, okay? Or line, I'm going to draw in the line containing the maximums and the minimums. That'll help you find your amplitude too, by the way. There's the line right there that contains the minimums. Here's the line that contains all the maximums, all right? And I'm going to get the equation of those lines real quick, all right? This one is y is equal to, 5, okay? And up here, y is equal to 25. Well, the distance between those is 20. Half of that is 10, so if you add 10 to this bottom line right here, you get y equals 15. Y equals 15 is going to be your midline, okay? So there's y equals 15, all right? By the way, that's also your d value. There's y equals 15, and that's d, your translation up, okay? All right, and here's your amplitude. We found that amplitude a minute ago. Your amplitude is the distance between the maximum line and the middle, so that amplitude A could be equal to 10 or -10. You could do either one. I'm going to do 10. Okay. All right, now my period is the distance from one maximum to the next maximum, or from one minimum to the next minimum. It really doesn't matter, okay? So maybe we should start from this maximum here to that maximum. This point has an x-coordinate of, by the way, the coordinates of this thing is, that's 8, 25. All right, this point has 25 as its coordinates, if you like. All right, the 25s don't matter. The distance from 8 to 20 is 12, all right? So 12 is your period. So your period, your period is equal to 12. Now, I'm going to find B real quick by setting that equal to 2 pi divided by the absolute value of B. All right, multiply each side by the absolute value of B, or B, same difference, is going to give you 2 pi divided by 12. The absolute value of B would be equal to pi over 6, all right? Which means B could be equal to pi over 6 or negative pi over 6. So we got B, we got A, we need C. If I'm going to do a sine, the phase shift would be the horizontal distance, or could be, let me state it that way, could be the horizontal distance from, sine normally starts going from the midline going up. Well, if I'm going to do that, I would need this distance right here, and that distance, I do believe, is 5, so that means C could be 5. I could go all the way out here, you need to realize that, but I'm just going to use that value of C. I've already got D, so I've got everything I need for a sine graph. So for this sine graph, I would use my A value, all right, which is 10, times the sine of my B value, which I found to be, where's B? Pi over 6, all right, pi over 6 times x minus my C value, 5, close parentheses, plus my D value, which is 15. Now, if I had written a cosine function. The only thing that would change would be my phase shift, okay? All right, and if a cosine starts at a maximum, well, that's the distance from here to here, all right? Which means that my C value for a cosine would be equal to 8. Everything else would stay the same, okay? So y would be equal to 10 times the sine of pi over 6 times x minus 8, close parentheses twice, plus 15. All right, now let's go do that last one real quick. First thing I'd say is let's graph the line containing those maximums. All right, so here's the line containing the maximums. Then let's graph the lines containing the minimums. And let's find the distance between those two lines. All right, this line right here looks like y is equal to -1. This one looks like y is equal to 1, 2, 3. Okay, the distance between those is 4 units. Half of that distance is 2. So I can go 2 units below this one or 2 units above that one. It wouldn't matter. There is your line, your midline. Y equals 1, and that's your D value. All right? Excuse me. That's your vertical translation. This distance from between those two, that distance right there, is your amplitude, and that's 2. So A could be positive or -2. I'm going to make it easy and leave it as positive 2. I've got A. Now I need B next. B is the, well, in order to find B, I'm going to find my, I'm going to find my period. I'm going to find the period from the first maximum to the second maximum, okay? All right, this is 2, and that is 6, and 6 minus 2 is 4, so the period of this sinusoid is 4, okay? And that means I'm going to take 4, the new period, and set it equal to 2 pi divided by the absolute value of B. Multiply each side by the absolute value of B. 4 times the absolute value of B equals 2 pi. Divide by 4. The absolute value of B would be pi over 2. So B could be plus or minus pi over 2. I'm just going to use the positive and make it easy. Okay? All right. I've got D. I need C. Well, I'm going to find C as, let's do a cosine since I did cosine in blue a minute ago. Cosine starts at a maximum. So if I'm going to find the horizontal distance from my y-axis over to the first maximum, and that would be a C value of 2. So my cosine equation could be y is equal to my amplitude, A, which is 2, times, I wrote a cosine first, and my B value I found over here. Here's my B value, pi over 2, times x minus my C value for the cosine would be 2, close that off, plus my D value, which was positive 1. All right, now I'm going to real quickly go back and write a cosine equation. Well, cosine starts on the midline going up, okay, normally, okay, or going down. That means my C value would be 1. Everything else will stay the same, okay? So y equals 2 times the cosine of pi over 2 times x minus 1 plus 1 will be my, or minus 2, excuse me, that's a 2. That C value, phase shift changed. Oh, it's supposed to be a 1. It was right, that's a 1, my fault. All right, there's your equations. If you have any questions, please give me a call or show up in a Google Meet or give me an email or whatever. Thank you, bye.